Ever wonder how your favorite app can handle millions of people all at once without just completely crashing? Well, today we're going to pull back the curtain on the incredible engineering that managed to tame the data explosion and really build the internet we know and use every single day.
This is a question that almost broke the internet. As more and more people flooded services with photos and posts and clicks, the systems that were built back in the 20th century, they just started to buckle. Websites would slow to a crawl, databases would crash, engineers were facing a challenge on a scale nobody had ever seen before. So what was the big breakthrough?
To really get this solution, first we have to understand the problem they were up against. And it all came down to one single critical choke point in how we used to manage information.
For the longest time, the model was pretty straightforward. You had all your users and all their requests funneled through one giant central server that was connected to one giant database. It made sense at the time, but it had a fatal flaw for a world that was about to see explosive growth.
And that flaw was scale. As the amount of data just skyrocketed, trying to force everything through one central point was like trying to funnel an entire river through a garden hose. It just created this massive data traffic jam, a bottleneck that made everything agonizingly slow. The old way it couldn't scale. No way, no how.
So how do you solve a problem that just keeps getting bigger and bigger? Well, a team at Google came up with this really elegant solution, borrowing from a strategy that's, as old as time: divide and conquer. They called it MapReduce, and the core idea was pretty revolutionary. Instead of trying to build one, impossibly powerful supercomputer, they thought, hey, what if we just break a huge job into thousands of tiny pieces and then spread them out across a whole fleet of regular, off-the-shelf computers, all working at the same time? So here's how it works. You start with this huge data set. The map phase is kind of like a dispatcher. It splits up the work and sends these small, manageable chunks to hundreds or thousands of computers to process all at once. Then, after they're done, the system shuffles and sorts all those partial results. And finally, the reduce phase gathers them all up to put together the final answer. Yeah, it really just boils down to those two main steps. Imagine you had to count every single word in an entire library. The map step is like giving one book to each of 1,000 people to count at the exact same time. The reduce step is just collecting all their individual totals and adding them up. It's a surprisingly simple solution to a gigantic problem.
But you see, fast processing was only half the battle. The other huge problem was storage. The way we were structuring our databases was just too rigid for the messy, chaotic nature of internet data. It was time to break free from the table. For decades, data lived in what we call SQL databases. Think of a super strict spreadsheet with very structured tables and predefined rows and columns. But internet data, user profiles with new fields, photos with different kinds of info, unpredictable social media posts, it was messy. And trying to cram all of that into a rigid structure was becoming basically impossible. The answer was this whole new philosophy called NoSQL. Now, the no doesn't mean a rejection of SQL, it's more like not only SQL. It was all about embracing a world where data didn't have to fit into these neat little tables. The priorities were flexibility and the ability to scale out across tons of servers.
And NoSQL isn't one single thing. It's more like an entire toolbox. Instead of a one-size-fits-all approach, it gives you specialized tools for different shapes of data. Does your data look like a self-contained document? Or maybe a web of connections? Or just a simple key and a value? Well, there's a model for that.
You've got 4 main flavors, and each one is good at something different. Document databases are awesome for things like user profiles. Key value stores, incredibly fast for things like caching. Column family stores can handle just massive datasets for analytics. And graph databases are perfect for mapping out relationships, like in a social network.
So let's make this real. Let's look at 2 titans of the NoSQL world, technologies you probably interact with every single day, whether you know it or not.
First up is MongoDB, a document database. Its real power is its simplicity. Data gets stored in these intuitive JSON-like documents, so if a developer needs to add a new piece of information to someone's profile, they just add a new field to that person's document. You don't need a complex database redesign. This kind of flexibility means you can develop things incredibly fast. And our source material really nails it when it says this design is built for 2 things: scale and speed. You can scale it out by just adding more servers, and its flexible model gives a huge boost to developer productivity. All right, our second titan, Cassandra, was literally forged in the fires of scale over at Facebook. It was built to power their giant inbox search feature, a problem that needed pretty much perfect uptime and reliability. Facebook later open-sourced it, and the project just took on a life of its own.
Cassandra's superpower is its always-on architecture. See, data isn't held by one single master server. It's copied and spread out across a ring of different computers. So if one machine fails, the system literally doesn't even skip a beat. Others have a copy of the data and just seamlessly take over. It's a masterclass in designing for high availability with 0 single points of failure.
So, when you put it all together, MapReduce and NoSQL, man, these weren't just small improvements. They were a total paradigm shift that completely rewrote the rulebook for building large-scale applications.
Let's just recap that transformation, right? We went from centralized systems to distributed ones. We engineered away the single point of failure to get high availability. We broke free from rigid schemas to embrace flexible models. And by doing all that, we traded those crippling bottlenecks for blazing speed.
And here's the kicker. The reason this all really matters to you. This isn't just some abstract theory. It's the invisible engine that powers your digital life. The reason your social feed loads in a blink, or your movie stream never buffers, or online stores can handle millions of shoppers at once, it's all thanks to these foundational shifts in computing.
These innovations, they solved the data crisis of their time. But the data deluge is only getting larger and faster, right? It's being fueled by AI, the Internet of Things, and technologies we haven't even thought of yet. Our whole world runs on this foundation, which leaves us with a really thrilling question. What comes next?